Here's the solution for day 2, problem 1. A polygon is graphed below. It is reflected over the line y equals 1. Graph the image. So the line y equals 1 will cross the y-axis here at 1, and it's a horizontal line. This line is our reflection line. So to reflect this polygon to the other side of that line, we can reflect each vertex point to the other side of the line and retain distances. So point A is 2 units from the line y equals 1. So let's move 2 units to the other side of the line to find its image, which we can call A prime. Point W is 3 units from the line of reflection. So 3 units to the other side of the reflection line is W prime. M is just 1 unit away from W, and so 1 unit away from W is M prime. And point D is 2 units to the right of point M, and so we can move 2 units to the right of M prime to get D prime. Let's connect these dots together to have our figure. We want to make sure that we have created a picture that is exactly the same size and shape as the original, but it is the mirror image of the original over the line y equals 1. That takes care of question A. Now question B, what are the coordinates of point W prime? W prime is located right here, and this spot is the origin of our grid, so that's left to -1 and then down 2. So W prime is at -1, -2. Now, day 2, problem 2. Triangles are drawn below and congruent parts are marked. Are the triangles congruent? If yes, identify the postulate or theorem used as the justification. So here we have the triangle on the left, the triangle on the right. Is there enough information to know for sure that they're congruent? We have an angle here and an angle here with the same kind of loops. That means that those angles are congruent. This side of the triangle has this little mark on it, and over here on this triangle, this side has the same kind of mark. That means that those sides are congruent. Now there's one other pair of corresponding parts that are congruent. They don't have marks in them, but let's mark them ourselves. This angle right here and this angle right here are created by these intersecting lines. These are called vertical angles, and there's a theorem in geometry that says vertical angles are congruent. Let's put double loops in those 2 angles. Now we do have enough information to know for sure the triangles are congruent. So our answer is yes, they are congruent, and our reason is the angle, side, angle postulate, or for short, the ASA postulate. This postulate says, if 2 angles and the included side between the angles are congruent to 2 angles and an included side in another triangle, then the triangles are congruent. And that's the situation we have here.